Hello and welcome to the latest webinar in the Elemental Talks program. Our topic today, how can we future-proof the growth of UK heat networks? It's our session sponsored by Altechnic, part of the global Calefi organization, your chair for the next 60 minutes or so. My name's Jim McClelland. I'm founder and editor of SUSMeme, home to both the magazine and the top 500 rankings. Joining me on the panel this afternoon are Gareth Jones, managing director at Fairheat, Alex Maguire, Director at Flow Consulting, Selene Molina Blanco, Lead Engineering Manager at Vattenfall, Håkan Knutsson, Sustainable Heating and Cooling by Sweden, welcome from Scandinavia, and Neil Parry, Head of Specification at Altechnic. It's all live with a Q&A to finish, and you should see a little Q&A box on your screens, audience. That's where, as the name suggests, you can pop your questions and I'll be able to ask them hopefully at the close of the session to the panel. A little bit about Elemental. This webinar forms part of a program of talks hosted and produced by Elemental, www.elementalexpo.com. It's the online community for professionals focused on innovation and heat, water, air and energy, the vital elements within the built environment now and in the future. You can find a full diary of events on the website with a range of upcoming webinars. You can also view a back catalogue on a whole host of topics, all available on demand, great who's who of speakers, and everything is free to access and share. There are also some in-depth interviews, one-on-one, and some longer form articles on the Pulse. So lots of infotainment to enjoy. So we have a very busy program today. So by way of a really brief intro from me, future-proofing growth. So as soon as a critical building block in the recently released sixth carbon budget, heat networks are targeted to meet towards 20% of the UK's low carbon heat requirements come 2050. Given that they've only been delivering about a tenth of that to date, the scale of the task and the extent of the country's net zero ambition is clear. The government's a strong advocate for the energy efficiency and cost-effective attributes heat networks offer both the promise of carbon reduction and, of course, lower bills, ideally for consumers. The question remains, however, how this dramatic growth rate can be achieved successfully with minimum operational risk. In short, the webinar is going to explore how we can future-proof that rollout of UK heat networks. Our discussion will assess the impact of innovation in the marketplace, as well as looking at continuous commissioning, support for advanced management tools, and recent guidance updates, including CP1 2020 Code of Practice, published in January, big upgrade on the 2015 version. By way of context as well, we shall also look at lessons to be learned from success stories in other countries and regions, such as Scandinavia. So that's what we're looking at within this next hour. We'll get straight into it, exploring the strategies for future-proofing the growth of heat networks here in the UK and lessons to be learned. So I'd like to start by asking each of our panelists to introduce themselves, explain their perspective, share some opening insights. So briefly, it's a kind of who are you, where do you fit into the puzzle? What, in your opinion, is the state of play right now with the rise and rollout of heat networks? So first, opening thoughts from an expert in energy efficiency. Gareth.
Jim, thanks for that. Afternoon, everyone. My name's Gareth Jones. I'm Managing Director of Fairheat. Fairheat's a specialist consultancy that provides quality assurance to heat networks. We actually work, there's two sides of the business. We work on new build projects, everything from energy strategy through to delivery. Slightly different role in the sense that we're working alongside other design consultants, contractors, others in the market, and really providing that quality assurance oversight, do a lot of testing and making sure that systems deliver correctly. On the operations side, we do everything from monitoring of systems to make sure they're keeping on going. But unfortunately, actually quite a lot of our work is also looking at systems that are not performing and looking at how do we turn those around. Overall, we've worked over 200 different heat networks in the UK, so we've got quite a lot of experience around that and seeing what works, what doesn't work, and sort of, I guess, if what we try doing is taking information from what doesn't work and what does work and feed that back and try closing that information feedback loop. Regards to state of play, it's fascinating times. We're at it's a transition point in the industry. We're seeing a big shift away from gas CHP and gas generally, heat pumps. We're seeing lots of projects come through heat pumps, which is quite exciting, but also quite scary as there aren't very many out there at the moment. So we've got quite a lot of challenge around that. And what we need to do with heat pumps obviously requires a totally different approach and the sort of temperatures that we need to look at. So there's quite a lot of delivery risk. Same time, there's quite a lot of change coming through the pipeline with regards to upcoming regulations, which are a challenge, but I think really necessary. Focus needs to switch on to consumers. So exciting times.
Excellent. Yeah, exciting times. A lot of transition in the air, a lot of performance questions. So, Alex, turning to you as a specialist in resolving performance and refreshing engineering, what's your take on things at present?
Thanks, Jim. And thanks for the link to our strapline. My background is that I've had about 25 years in the industry, principally mechanical engineering, thermal modeling, analysis, building physics. I was a partner in a practice for around 10 years, and I got a little frustrated with the business as usual approach that was adopted by more traditional partnerships, and wanted to be part of something a little more dynamic, a little bit more responsive, and something that understood and was at the cutting edge of technology and resolution. So I founded Flow around 4 years ago, and since then we've been growing steadily and doing just that, looking into problems on projects, trying to instigate best practice design in projects, and heat networks is one of the areas that we focused on. But I will say we do focus on everything and look at the complete building services solution, because I think it's very important to know that even though heat network is a big part of a development, it interacts and has an effect on everything, on many other installations. So where are we going? We are at a turning point, as Gareth says. I think overnight we've seen a shift now with the decarbonisation of the electricity grid over to the incorporation of heat pump technology within heat networks, and I'm still not convinced that that's the best approach. I certainly want to see some trial installations out there, certainly want to have a look at those, and want everyone to learn some lessons from how they perform, because I think if you just look back at the recent deployment of heat pumps on smaller scale individual dwellings where they've been used for residential heating and domestic hot water, there are a number of examples where they haven't performed particularly well, and that's where you've got one consumer as opposed to numerous. Counter to that, there are some very, very successful projects, and friends of mine who have heat pumps at home absolutely love them, don't pay much to keep them running and swear by them. But those friends are friends in this industry who know what they're doing. I think we've also got to remember that our industry is cyclic, and we just need to look back if we're going to look forward. And if you look back, even in recent times, we've had CHP and biomass which have come in and fallen out of favour. Before that, we've had heat networks that have come in and fallen out of favour. Before that, 70s, but probably, we had steam, some coal, oil installations as well. So we are cycling through the process, and we've got to learn from the lessons that we've had. And I don't think anyone can forget some of the problems that we had with CHP when that was trying to be rolled out, and now it's just been steadily pushed to one side and not being used much more. So I think there's some interesting challenges ahead in respect of energy generation.
Excellent, thank you. And yeah, and let's hope that that process is evolutionary. Let's hope we're learning as we go. And in terms of learning lessons, I'm very pleased to have Håkan joining us from Sweden. And I wonder, please, if you could give us your perspective as a pioneer in heat networks. Where are we at present, please, Håkan?
Okay, thank you, Jim. Very briefly, I have been in the energy industry for about 30 years in power industry, power distribution and transmission, and in district heating. And I'm an advisor of sustainable heating and cooling by Sweden, which is an initiative sponsored by the Swedish Energy Agency and Business Sweden. And I'm also the chairman of SWEHEAT, Swedish Council for District Heating. And in this group, I must be humble and admit that there are many historical reasons why we are blessed with sustainable energy systems in Sweden, both for heating and cooling and electricity. And I'm not going into those details, but district heating has a 50, 60 years of history in Sweden. When Western Europe were choosing the pathway of gas, the Nordic countries were choose the pathway of district heating, basically. And today, district heating has 50% market share in Sweden in total of all the heat market. And the other 50% is more or less electricity-driven heating and heat pumps, mostly today. Many industries are also using district heating. Let's say looking for the future, I think the perspective by Alex and Gareth is quite the same for Sweden. We see the district heating is mature, so it cannot grow very much to capture more market share. What we see today is even more sector coupling to the power production and also carbon capture and storage. We would probably see large combined heat and power plants fueled by waste or biomass that will have carbon capture and storage. And we also will see, we have a lot of experience of heat pumps in Sweden. That is the big competitor to district heating. And I believe we will see hybrid systems coming, a combination of district heating, heat pumps, thermal boreholes, and cooling. So that is kind of future looking.
Excellent, thank you. Yeah, nice to have a perspective from, as you say, a more mature market, a good way further down the path than ourselves, for sure. So, and now this year's rising star of the Decentralized Energy Awards, no less. Selene, your perspective, please.
Hi, Jim. Thank you. Hi, everyone. Nice to be here talking about this exciting topic today. I'm Selene Molina Blanco, lead engineering manager for Vattenfall Heat UK. So as Vattenfall, we're Swedish state-owned company, so we've been playing in the Swedish and European market for a while, but we set a heat business in the UK about 3 years ago, with the aim to build and operate large-scale, low-carbon heat networks. So we're targeting big customers, big places, develop scaled networks. I believe that in terms of the state of the market, it's at an exceptional place right now. There's a lot of backup from the government. There's HNIP. There's the new Green Heat Networks funding. The 6th carbon budget target, as you said, Jim, or like where they said a potential 20% of the heat by 2050 could be provided by heat networks. I think it shows how big opportunity this market is, and the amount of work that's left to do. So if anything is exceptional, it's going to grow. It needs more and more people. It needs innovation, and it needs learning from lessons, as the other panelists were saying. So I think it's an exciting market to be in. Yeah.
Excellent, thank you. Yeah, exciting times, big opportunity, but a long way to go, and the clock is ticking. We don't have forever to get there. 2050 will come up surprisingly fast, believe it or not. And Neil, finally, insights on specification from a leading solutions provider. Your take, please.
Thanks, Jim, and hello everybody who's on the call. I'm an engineer. I've been involved in the building services HVAC industry for more years than I care to mention, as you can tell by the colour of my hair. I head up the specification team division at Altechnic, and we kind of approach the market really from the point of view of trying to offer more than just something in a box. So for us, we live and breathe heat networks every day. We see the issues that go wrong. We've been involved in the history, specifically myself, maybe, I don't know, 17, 18 years just on district heating alone. So we've seen all those, the things, the good, we've seen the bad, and absolutely, as people have said, we need to learn from that and move forward. So we see what we do in the market, not only as offering a product and a solution, if you like, but also, education, giving CPD seminars, that kind of thing. We have design guides, all that kind of thing, and that's really what we do. We do that with consultants, we do it with contractors and also clients, and it's just about getting the knowledge out there. Because we, being so close and involved in all the different networks, we have that information, and we're not wanting to keep it to ourselves. We want to really push that out. So it's definitely an education process. And the interesting thing is now, I think in the UK, for the first, I don't know, 10 years or so, we had very little data that we could look at and learn from. It was sort of, we were working on typical engineering practices, which may or may not have been applicable to heat networks. But now we've now had a number of years where we're starting to analyze the data that's coming back from energy meters installed within HRUs. We can see flow and return temperatures, and therefore delta T, and see from the meter how efficient a network is operating or not. And we can learn from that. And our CPD, aforementioned CPDs and design guide has really morphed over the sort of 15 years or so, and really moved quite rapidly over the last 3 years based on that data that's coming back. And I think that's only going to increase significantly when we now move to sort of smart HRUs, if you like, or eHRUs, where you've got things like Modbus output, where you can get data in a really high resolution. You can see each individual tapping of hot water demand to see what it actually is, how much energy are they taking from the network. So that will feed into the designs, and that loop back is what's really critical to move the whole design process forward, really. It may be that pace of change is so quick that it may outstrip the guidance documents and the regulation. Mm-hmm. We need to disseminate that out as soon as we've got it, so people can actually use it. And we also need to look at the current construction process in the UK, because it's quite siloed in many respects, that the individual disciplines have their own priorities, which may or may not lead to the best results at the end of it. So we need to address those and ensure that everybody has the long-term priority rather than short-term. So the priority being reduce the carbon implication of the building, reduce the energy use, and in doing so, also not to forget, of course, that we've got to ensure that the needs of the people living in the buildings are catered for as well. So as everyone's saying, it's a really exciting time, because we've got to make a change, and we've got the data which shows us what we need to do. So it's really good times. Excellent,
good points there. And a nice mention for the call for a more collaborative ethos, which has to work with that idea of a learning culture, in that all boats rising together kind of thing. So, however, in the middle section of this discussion, it's called challenges and conflicts. And I would like to zoom in on some of the specifics around this delivering of growth in a sustainable and resilient way. And I'd like to challenge our panel at this point around some of the problems the industry is likely to face, asking why we still have so much yet to do, as Selene referenced. So what are the problems? Is it innovation, regulation, cost, culture, skills? What changes need to happen to put heat networks on the map in the UK? So starting us off in this section, Alex, the road to project success is long, from system intent via design and engineering, performance and operation. So where do most heat networks go wrong most often? I'm asking you briefly to point the finger. Where are we falling down?
The quick answer is that there isn't one answer. There isn't a silver bullet there, if you like. There are many stages to the design development. So forgive me if I jump around a little here, but I think that firstly, the design basis, the feasibility for the network has to be sound. If it's not sound, it will never achieve the desired effect. It will never be as efficient as it could be. It will result in some kind of dissatisfaction. There will be some compromises. So the application has to be considered. The feasibility study has to be undertaken appropriately or correctly, should we say, and in sufficient depth to confirm that it's the right approach. I think following a logical design process, and crucially, not necessarily a design process that applies to traditional approaches of design. And I think a little bit of context there is useful in that you don't design heat networks how you traditionally would design a heating system. They're quite a different animal to what most engineers would typically see as being a heating system or a heat network. They don't often join the dots to say, well, this is quite different. It's fulfilling a number of different functions or has to perform quite differently. So following a logical approach to the design and optimizing that design and going beyond what have traditionally been our comfort levels or our boundaries, if you like. So Neil mentioned having been in the industry for 15, 16, or not the industry, sorry, Neil, in heat networks for 15 to 20 years. I actually met Neil around about that time when we looked at what was my first heat network then, and that was a coastal site with biomass boiler serving converted maltings houses, which were residential, and that was all completely new to me at the time. So I knew the principles of heat and design, of course, but applying that to a large scale heat network using a different fuel was quite different. So that was before there was any guidance in the UK for heat network design. So using Neil's resources then, looking out to Scandinavia, to the standards that were being applied then, and actually challenging what we would traditionally do, I think was absolutely critical to the success of that heat network. And that was quite a while ago. Now, the interesting thing is that we come up against schemes now that still don't consider some of the principles that we were looking at back then, let alone how much the market has come on since. And I will say that, you know, credit to people like Gareth and Fairheat is essential, because what Fairheat have done is they've created a set of design principles that they've been confident enough to put out there and say, look, guys, this is what you need to do. We appreciate it's not in or wasn't in CP1, and I like the fact that the new CP, it's like reading Gareth's technical requirements, you know, when you look at the new CP1, and that's absolutely essential. So not learning from or not taking the information that's out there, not looking back at the development of heat networks, and then not breaking the mold, not thinking that the engineer can do everything, because they can't. And I say that because I'm an engineer and I can't. We need to be realistic about our abilities, and then the performance of the network. And I also think that we don't need to overcomplicate the network. Again, I've seen a project that I'm reviewing for a client now where we're doing a technical assessment role, and there's 12 pumps in the plant room for the heat network, when really, you know, you could get away with certainly less than half of that, because people are just overcomplicating things to bring in other technology without fully thinking through the interfaces and interaction between those and the overall performance of the network. So simplicity, I think, is key. Now, rather than me go on and on and on, I'll probably stop there, because there are any amount of things I could start to see through efficiency, installation, etc. But I don't want to take up too much time, cover off things other people.
No, Thank you. A lot of key topics already in play. And what you say about expectations on engineers brings me nicely to the challenge I'd like to put to Selena, which is engineers love solving technical problems. We know this, but you're not magicians. So the likes of fourth generation district heating calls for new thinking on design standard skills. Now, without this more holistic approach, are client goals just unrealistic? Do they simply expect too much of their engineers, Selena?
I don't think they do. I think high expectations are key to push us to achieve the goals we need to achieve. I think we all agreed in the first questions answers that there's huge challenges to achieve and there's not much time to do it. So without high expectations, we may not have that push to achieve those goals. In terms of new thinking and I don't think that it's the new. It's very simple. Alex put it perfectly there. I think the key skills we have to have, not only engineers but probably everyone in the industry, is that holistic view. Is not only the end customer or the energy center or the primary network. If the end-to-end system doesn't work, then it's not going to work. It's about being able to recognize as well the our clients and customers' needs and the interfaces. I'm personally working on a project now where it's all built in phases, but it has to be built like that. We're dealing with high infrastructure, coordinating with other utilities. It's almost inevitable to have to design or look in detail at one section of a primary network underground on a road, and it's easy to maybe forget about how that links with the building down the road or the energy center at the other end of the road. We need that holistic approach. I think we need flexibility as well. Design standards and regulations are great, but I think we also agree that it's a fast-paced market and technology will evolve, and hopefully it doesn't happen with heat pumps, but I'm sure it's like the same as with CHP or biomass boilers, but it will definitely be not only the option. There will be energy from waste, and there will be direct electric heating when we play in the demand side response or with the power market. So there will be other solutions out there to which we'll have to be flexible and agile enough to incorporate quick enough. Um, and then as a third skill, humbleness, or I don't know if that's the word, but being humble. Learning from each other, learning from past mistakes, learning from that great example, Alex, you put there, 12 pumps. If you've like, yeah, learn from that, and if we give feedback or you give feedback to whatever design review you're doing the review of that design, that feedback should be taken and incorporated quickly in the next designs of that consultant or engineer. So, and I'm sure we all have to learn from each other. So we'll all have to be humble. And the other thing I wanted to say is with clients, if we don't make heat networks work and work well for the customers, we're not going to be able to build the confidence we require on heat networks to grow them at scale. So those high expectations and big goals are good to have, I would say.
Excellent. Some nice points there. And yes, it is a learning path, as you say, but there is also a need for market confidence, as you say. That is the two don't necessarily go hand in hand. And I think in any kind of strategic planning, especially around the energy transition, we've all learnt the value of flexibility and agility, particularly in hindsight post-pandemic, because of course an awful lot of strategy and plans have needed to be changed, and the whole idea of resilience has been taken up a notch, arguably. So Gareth, in terms of there are many issues that emerge over time. They're actually evident before a system even gets commissioned. We have the data, as people have been saying now, so why are we not using it to get it right first time?
I'm going to be a little bit cheeky here and say that would have been an excellent question 6 or 7 years ago. No, seriously, I think what we're seeing is that there has been a significant change. We did a review as part of a BASE funded project 5-6 years ago, where we found that about 50% of the performance gap. There's a big performance gap for, and this is, I think, comes back to the first times you do things, teething troubles. You know, there is an experience curve you need to move down. It takes a while to get right and get learnings in the market. And I think we are a long way down that now. But what we saw then is there was a big performance gap. It's now closed on a lot of schemes. But about half and half of that, so about 50%, a little bit more than 50% of that was design, the things that Alex was talking about before. Unfortunately, we're still seeing those problems now. And I think we have to make sure that, I'll come on to that, but we have to make sure design decisions are being made. And then the other half was actually around commissioning. It was all about this. And actually on that project, it was a project that should have performed in a certain way. So we went through and we actually we went and recommissioned a project, and we got almost 70% reduction in heat losses from the network. And almost all of that was because of exactly, they were almost all could have been seen right at the start, and it just wasn't being used. But I think what we're seeing now is, in most schemes we're working on, we are using that data. We're seeing fantastic results as an outcome. And when I'm saying fantastic results, I mean things are operating at or better than design. I'd love to be putting up graphs now of sites showing, you know, lots of sites with 30-degree return temperatures, and really importantly now also 60-degree flow temperatures. And we're getting that. Those are sort of, we're getting schemes that are operating at the level you need to have 4 heat pumps to be operating, and you know, it's less than 70 watts of dwelling losses. So proof in the pudding, we can see that it does work. I guess the question is why we're not seeing that right across the industry. And I think a lot of answers to that, but fundamentally, I think we've got this tradition where quality assurance going through and actually doing checks is still seen as an optional extra cost rather than actually being a fundamental part of the process. I think that's a big false economy. More than pays. You know, there's a lot of studies that show that more that going through and checking that things are done properly more than pays for itself by way of reduced callbacks from a developer perspective and contractor perspective, but also in terms of cost for residents. And I think part of the issue is we still don't have minimum performance requirements which are enforced. We have CP1 2020, as Alex was saying, is a huge step forward. I think there's lots of stuff, and if you follow that properly and actually go through and implement it, you will get good schemes, but it's still voluntary. And that's so I think BEIS has flagged that we're going to have minimal technical requirements as part of future regulations, and I think that's something that we need to be doing. And I think the industry as a whole needs to be thinking, actually, that's only 2-3 years away. That's tomorrow in terms of any projects we're looking at now. We absolutely need to make sure we're building these processes in. And then I think actually by using data, if you think through that, you will go through that process. It's just about measuring things and making sure you're doing the checks. And I think we can do it. And there are great examples of where it is being done and really good projects coming through. And actually, again, just one thing I will add to that, it requires collaboration, it requires people working together and not bristling. It comes back to Selena's point before. It's about the humbleness, or at least just being willing to prepare to speak to people and prepared to say, hey, yeah, fine, I might have got that wrong, but that's fine, I'll incorporate that. I think that's really, really important. And we're seeing changes on that side as well.
Excellent. And I think it's a nice point really about the idea of future proofing. In some senses, those timeframes are quite short. You know, the future's coming up really quickly. So within a matter of years, the scenarios you're facing today will actually be here. So yeah, so Neil, I mean, on that point, kind of, we know potentially performance deteriorates over time. We also know continuous commissioning of intelligent systems can save energy, cut carbon, but it can cost money. So my challenge to you is the onus not on a solutions provider just to make the business case better for smarter spend, to future-proof? In other words, sell the concept of fixing tomorrow's problems today. Is the onus not on you to pitch it better?
Yes. Next question.
Okay.
No, it is. Yes, I agree. There is an inherent problem in this, as we're a provider, we're seen as, oh, they're just a salesman, they want to sell their stuff. Does it really have a benefit? Is it really going to do all these things they say? They're just, trying to promote it, and that's the difficulty that we have to get over. But it is absolutely down to the manufacturer or the provider of the solution to actually promote it. Now it again comes back to data. You know, I think if you have the facts and the data from sites, then the case actually makes itself. It really is, you know, that simple. And there's coming back to one of the comments you said, you know, there's a terrible statistic, which hopefully I get this right, which is roughly that whatever the losses on a heat network at handover, they're doubled by within 3 years. You know, that's mind-blowing, really, in some respects. So we need to be able to see that, because if you don't see it, you can't manage it, as the phrase goes. But so we need to see it, and then we need to be able to address it. And how do we do that, and so on? And I think certainly from future-proofing with regards to the HRU side of things, that's actually relatively easy, because we know really where we're going. We know that the flow temperatures on networks are coming down. So we need to ensure that the terminal units, the HRU, can operate on those conditions. And the key point there is this, the actual difference in cost between sort of a HRU that can work at 70 degrees to a HRU that can work at 55 degrees is actually really small, really small. But again, it comes back to that focus, that who are we selling it to and what is their focus? Because the you know, if I make a figure up, the £30, £40 difference in cost is a difference in cost. So there is, are we focused in the short term, or are we focused in the long term? At the end of the day, it's the building that must win over, and it's the tenant and the owner of that building that must win in that competition, if you like. So that's something, literally from a HRU point of view. You know, even if a project is installed today and happens to have high temperature energy sources, whatever they may be, then with just a small amount spent onto the HRU that goes in today, means that at some point in the future, if we convert that plant room to heat pumps, then we absolutely can't put it back onto the client to go and rip out all that equipment he's installed and install all this new equipment to work at the lower temperature. We need to put them in now, and the cost negative is so small that actually it warrants doing that right from the off. That's one aspect. I think the other thing, of course, constant commissioning. Well, how do we do that? And this is again another case, business case, if you like, where I think the data will be king, because we've had there has been an elements in the past where we're pulling data from the meter, where we've got this stack of paper with all these figures on, and somebody's got to get his highlighter pen out and go through it and try and find what's going on and so on. I think we've now moved on from that. I think with the latest generation of Modbus output, we can massively increase the resolution of data. So instead of pulling it maybe every 15 minutes or so, we can now pull it every few seconds from a HRU. We can now see exactly what's going on, and we can convert that into a graphical output. And that's the thing, we have to remember that maybe as engineers, we tend to get a bit too close to things, and we need to be able to have an output from Modbus that is understandable for an engineer and understandable to a non-engineer, because somebody's going to look at this and need to make changes. I think the output from this kind of information that we can get via Modbus needs to be simple, like green light, amber light, red light, you know, nice and easy. There's a problem. Maybe it's a speedo that shows you the efficiency of the network in real time. Hang on, it's dropped down, what's going on? And we can address it. Maybe even coupled into that, things like alarms, where, you know, you have amber alarms that just maybe get emailed to somebody, but then you have red alarms which get texted to a number, and if there's no response after 5 minutes, it sends another one to somewhere. Integrating all that, it's about simplifying it. Absolutely, the network should be simple, but so should that data coming out. Having stacks of paper is useless to anybody, really. And I think once we can show that, once we can say, here you go, here's a nice dashboard, look at that, look at all that information, look what's happening in real time, then it's probably a salesman's dream, because, you know, as soon as he shows that, people are going to go, wow, why would you not want that? And the cost of doing it, I mentioned about, you know, a small cost from a future-proofing a HRU point of view, from the plate heat exchanger that's in there. In terms of Modbus, almost or a majority of the equipment that's required is already actually going on a number of projects. So the difference to change it to Modbus in terms of cost is actually, into decimal points of the construction of the building itself. And the energy saved, in a matter of a year or so, will far outstrip the cost of putting the equipment in the first instance.
Absolutely. A lot of challenges and learnings. And I've got one final one for Hakan, but I see already the questions are coming in on the Q&A. So a reminder to the audience, we're getting a couple now. Do type them in and we'll try and get through to as many as possible by the end. So Hakan, we have the benefit of you being here today because learning from the mistakes of others can save us time, money, even whole projects. So please share with the group, what were the kinds of lessons you learned the hard way in Sweden that we don't have to relearn? So what did you learn that we don't have to, please, Hakan?
That is a tricky question, Jim. If we look back on historically, the networks in Sweden are 40, 50, 60 years old, and most of them are still in operation. So there are district heating companies who have assets that are more than 60 years old. The pipe network, which is the heavy capital investment in the network. So I think the lesson learned from that is to spend extra effort on high quality construction work. Yeah. And that is still valid. And of course, heat supply plants and heat interface units have been replaced over the years. And actually also transformed. Today, the district heating network is almost 100% decarbonized in Sweden. But I think a reason that was thanks to that the network is still in operation, because it's a huge investment to reinvest in the network. I think looking at a bit on with reference to the UK, I think important is the compatibility trap. Yep. And that is, I think they made a mistake 60 years ago or 50 or 40 in Sweden to make the network compatible with oil or gas boilers with the high temperature systems, so the secondary high temperature systems. And my guess is today I've heard a discussion here about fourth generation or even fifth generation of district heating. And I think that is, if you really are going to roll out district heating in existing built areas, you have a problem with the compatibility, and probably it's worth to invest in the buildings also to allow low temperatures. What else? And also mentioned before, it's standardization. Over the years, the pipes and heat interface units have been very much standardized, and of course that means lower price, but also experience and higher reliability on robust equipment. Mm-hmm. And then a tiny mistake made in Sweden, that we actually allowed a small gas network in the southeast of Sweden. And today it still exists. It's quite hard to replace one infrastructure with another. I guess you struggle with that in the UK. And today this gas network, it's maybe like 0.1% of the total heat market. Today that is fed by Danish biogas. So we could say that you buy the bacon from Denmark and we buy the manure, maybe.
Excellent, thank you. So yeah, there are compatibility trap, standardization, and issues around buying bacon or manure. So yeah. Nice points there. Thank you, Hakan. Excellent. Now we've got a couple of questions already. So this third round of questions from me, I'm going to put you under pressure, panel, to be really quick, and I'm looking for kind of 1 minute responses, and this is the positives and hopes. This is the cheerful bit. So we're looking at how successful and sustainable approaches can actually get us where we want to go. So these are kind of snappy 1 minute responses, and we'll take a couple of the questions before we close. So Neil, First, out the blocks, quickly. How can manufacturers drive the agenda such that government goals are achievable? How can it be done?
You want a snappy approach, and you came to me first, Jim.
I know.
Difficult for me, as anyone who knows me will attest to. Okay, we've got things, haven't we, really, here? We've got existing housing stock, we've got new build. I think, you know, if we're going to meet the requirements set out, we're going to have to address existing stock as well as new build. New build, you know, we really know what we should be doing. We're learning all the time, so on. But, you know, we just need to make sure that whatever equipment goes in on new build, it is future-proofed, as we've talked before. So I'm not going to repeat that. So existing housing stock, how do we do that? And that's where it gets a bit difficult, because obviously it's very diverse. So how do we do it? And I think we need to look at the cost of district heating in the UK, because it's higher than it is in Scandinavia. Why is that? You know, because the higher the cost of installing district heating, the more you have to look for sort of the more condensed areas of people using it, and we need to spread this out to where the existing housing stock is. So that would need to be addressed. But any manufacturer developing a product needs to make sure that that product is flexible, and it needs to be able to work under different conditions to meet the different conditions you see in the housing stock. And I do think that the manufacturers need to become experts in this, but not in their own product on its own, but in the system as a whole. And if that means you know, employing new people who bring in new ideas or new knowledge from different areas, or really partnering with other companies who are specialists in certain areas, that's what we need to do, because we need to understand the system holistically, and that's the really key thing. It's no good being an expert in one little aspect. You've got to understand system engineering and the system as a whole. And my final comment really is, you know, we have a unique position at the moment where we can see into the future, because we're all on the efficiency arrow, and the efficiency arrow only goes one way, and we know which way it's going, so we know where we need to be. So we've got that foresight, and we as manufacturers need to welcome that insight and be investing in R&D to develop products that move us further along that arrow, because we all need to go that way. And that's my bit.
Excellent, thank you, Neil. So mention of existing stock, expertise, flexibility, and a call for holistic thinking. Hakan, nice to have you here today, and I know you're an international ambassador wearing a number of hats and organizations. And my question to you is kind of, how can industry collaborate better to share best practice country to country, potentially, to help everybody speed forwards?
Well, yeah, I think the global district heating industry is a very friendly and open industry compared to many other industries like manufacturing. So my experience is that they are not really competing head to head, district heating companies. So usually they are very friendly to share information. I think the benchmarking between them is important, and visit each other. And for sure, anyone from the UK are welcome to come and visit us in Sweden, and we could try to to show what our experience, and I'm sure that you will have such a lot of new experience, and probably you will speed ahead of us when it's coming to the new generation of district heating. So and also let's say the commercial reality today is very different than 40, 50 years ago. All the networks in Sweden were constructed under municipality ownership. Today it's mixed ownership, but I'm sure we could learn a lot from the UK, and you are welcome to visit us, and we could demonstrate things for you. And I think benchmarking in general could be more efficient, detailed benchmarking down to heat interface units or control algorithms or whatever.
Excellent, thank you. So good plug for benchmarking, and a nice open invitation as soon as travel restrictions are lifted. Obviously, the whole of the UK heat networks industry will be heading to Sweden. So there you go. Make sure to stock up. So Alex, your quick final one. How can creativity and vision be harnessed to transform the way we work? A quick minute on that kind of uplifting vision for us there, Alex.
Okay, quite simply, really, I think we as designers or instigators of heat networks in some fashion, we have to be honest. So we have to be honest about our abilities. We have to be honest about the things we know and the things that we don't know. We have to be collaborative. We have to work together, use forums like this, share experiences, share the lessons learned, use that data to drive change and be dynamic, drive change in how we actually do things, how we actually perform. And then over all of that, I think that all engineers have to use their vision effectively. And one of the ways that I do things when I'm looking at a problem or I'm looking at a system, and if I'm mentoring engineers or students, I tell them to walk through the system, be part of the system, think about what it's doing step by step by step to give you a better understanding of what it is that you're designing. Bringing all of those tools together, which we all have, there's nothing special there, bringing all of those together and applying them to whenever we are looking at a heat network or any other schemes will breed success.
Excellent, thank you. So call to be honest as well as humble, and to walk it through. Now, Gareth, your 60 seconds. How can you get people excited about efficiency in the pursuit of excellence? So get us excited, Gareth.
I'm actually going to sidestep getting people excited about efficiency entirely, because people don't get excited about efficiency. What I do is say, I think if you take a user-centric approach, people get excited about creating spaces that are comfortable to live in, and where if you open the hot tap, then hot water's delivered quickly and it's comfortable, and it just fades into the background and no one ever has to go and deal with it. It's just reliable and it's there, and giving people really good customer experience with reasonable priced energy. I think if you do that, and that's what heat networks are really well set up to, the great thing about heat networks is that all of us geeks can get really excited about central plant and operation and how that works, and all you need is the data and how to visualize it. And I've noticed when I write posts, I can write whatever I want, and you get a certain number of hits. But if you put up an image showing people, here's a heat network and here's how it's performing, I get loads of hits. And I think people can, as soon as you show people data and show them actually how it's actually operating, people do get excited about that and they take notice. I think that's where you do it. You replay it to people and show what can be achieved. So user-based approach and data.
Excellent, nice. Putting the UX, the user experience back in it, putting people back into the equation. And finally, Selena, so you, so how might a heat network success story help the sector attract and retain top talent? Because we're going to need the people to deliver on this growth. So how can it help, Selena? I think you're still on mute. There we go.
Yes, sorry. Success stories will obviously help, but that's like easy. If something works, it's easy to want to like jump onto the train. But I think we have to be loud about the challenges and opportunities. So you said before, engineers love to solve problems. I agree with that. But I think anyone, not only engineers, that has that wants to make an impact and make a change on to solve the climate crisis and be part of this has a huge opportunity here. So I think it's about being loud about the challenge and the opportunity to attract people to it, and make people want to work together in this industry and others to solve the wider problems. Again, it's not about only solving that 20% target of heat networks. Is the whole 80% reduction in carbon emissions on the UK. And what I personally like about heat networks is that it's one vector of the energy transition. So it's about not working in silos. We can work with a power networks, with demand side response, with even transport, and I don't know. There's many ways to work together to achieve the common goal. So yeah, summarizing, being loud about the challenge and getting people excited about being part of it.
Excellent, thank you. And right, this is where we'll move now to the live Q&A, and we've already got a couple of questions in here. So if you want to put, I've had one from Twitter as well, but if you want to type them in the Q&A box, and we'll jump straight into them because we've only got a short bit of time left. So the first one, actually, maybe Neil, I'll cue you up to start this one, because Alistair Moore asks that you mentioned heat losses on a network can be double after a couple of years. To protect the client and their tenants or homeowners, does the panel recommend the network is retested before the final retention payment? So Neil, I don't know if you want to start us with a little about should it be retested to avoid that kind of doubling of losses dramatically?
It depends entirely on what's installed. If we're looking at maybe an older system that has effectively standalone equipment, if you like, that you can't access over the IoT, then it's very difficult to do anything other than to go back and retest after a couple of years. From the finance side of things, as a manufacturer of the equipment, I've been paid. Very easy for me to go, oh yes, retain the money. I think Alex may have a different opinion to that. But if we're stepping forward and having HRUs that where you can continuously commission, of course, then you can see that data constantly. You can in real time. So in that instance, no, there's no need to do it at all. You can make the running changes, because very often, why does a building drift over time? And it's an aggregation of little changes, really, that has that effect. Now, a lot of those things are outside of the HRU. It's not just settings within the HRU that are changed. It could be, some valves on the network that are altered when somebody's thinking of trying to fix something, not realizing what they're doing, and so on. But there are a number of things which can be done from the HRU side. And if you have that connection over the IoT, then you can just do that instantly, straight away. So that would be my take. It depends on the equipment, really.
Excellent, thanks. And Gareth, hand up, you want to contribute there?
Yeah, I think to be honest, network losses shouldn't be doubling. In fact, if you're looking and sitting on top of it, the key is to put in place the management structures to ensure that it doesn't, and be looking at the data and going in. And there are lots of schemes that show that can be done, and the performance continues. But at the same time, from a contractual perspective, when you get to the DLP, I would very much do a review, make sure you've got all the documentation you've got. And as much as anything, it's about pulling together all of that documentation, and during that period, and making sure you've got an evidence pack at the end, and actually going through and doing the tests, doing the checks, that it's all there, so that when you get further down the line, if anything goes wrong, for example, you've got issues with water quality, you can demonstrate this is exactly how it's been performing during that period. And yes, I would want to go through and check, get the sign off there, make sure that that's in place before you go. So as a practical matter, I think, Alistair, yes, I would recommend that.
Excellent, and good question starters. And now Chris Twin asks, he says, given the basic physics of heat pumps mean relatively little efficiency benefit between having them on building versus district heating, does this mean that district heating should focus on accessing large waste heat sources to enhance their heat pump efficiencies to enable offsetting inherent higher distribution losses, etc.? So, good long question there. I want to throw that open to the panel. Alex, did I see you putting a hand up?
Yeah,
looking to answer that. If you'd like to take that one from Chris, please.
I think that the first distinction to be made there is that that's not necessarily a question about heat pumps. It's about a local heat network as opposed to a district heat network. So the principles that you're asking about, whether it's on a building and a heat network within a building versus a heat network serving multiple buildings, are the same. The differences are the network in between them, which will have a loss. There's no doubt about that. There will be energy lost from it. But the trade-off then is the increased diversity that you get in your central plant. There's the reduction of the number of assets that you have across the estate. And when you factor those into the design of the heat network, you'll often find that the life cycle of the central plant serving multiple buildings will be better than that with a effectively decentralized local building approach. So there's a lot of other management issues associated with it, management, maintenance, asset replacement, etc. the question about the waste heat and the integration with heat pump technology is a challenging one, because something I've been looking at lately is the temperature steps with heat with different plant components in the central plant, and a lot of that depends on the temperature on the performance range of the refrigerant and the temperature glide of that refrigerant to make sure it's got stability at the temperature that you're operating the heat pump at. Where you interface that with the waste heat that you get from the network is critical. So it is hugely dependent upon what energy you can get and whether it can be beneficial to the arrangement of the plant in the case in question. And again, I'll say that the waste heat needn't be termed waste heat. It might be biomass, it might be gas boiler, it's just another energy input into the equation, and the interface between those different energy inputs is absolutely critical to central plant performance.
Exactly, and I think in more progressive sustainability thinking and speaking, I think the whole use of the word waste, I think, is problematic, really, in that it's all about resource flows rather than waste per se, but I understand where it comes from. So we are just about the final minutes here, and I have one question that's come in via Twitter, and I'm probably going to put it to the panel to see if we can close with a simple, pretty much a one-word answer, because I'm going to give you a choice here that the question is, who should be driving the heat networks agenda? And they've given a choice. Is it national governments? Is it regional or local or cities? Or is it ultimately the private sector? So I'm going to ask you each if you'd pick one, and only one. I know it should be all three, but pick one. Who's going to be driving this agenda going forward? National governments, regional communities and cities, or the private sector? So here we go. Hakan, a few starters. Which of those three you're picking? National, regional, or private sector?
Private sector with support from public.
The other two.
Selene, what's your choice of the three?
I'd say local. Each local area have their own energy sources. It's more dense or less dense, etc. So I think a solution can be found for.
Great. So we have one private sector, one local. Alex, what are you picking?
So qualifying this that it has to be everyone and it has to be applicable to the project, yada yada yada, etc. I think national government. For me, it's national. Policy has to be forced. We've got the same across the board: decarbonisation, EV, etc., etc. It has to be government.
So we have one for each so far. Like the Euros, we're heading into extra time virtually. So Gareth, what are you picking for? Is national, regional, or private sector?
If I have to go for one, it's regional, but you have to have a permissive central government. You know, the policy has to be right behind it, and I think it's very much a very difficult question, because you're going, which is most important when you have to have the elements.
Exactly, but that's the fun of asking this kind of question. And finally, Neil, to you then, what's your pick of those three? National, regional, or private sector?
Holistic. All three.
Otherwise known as ducking the question.
No, I'm not going to duck it. National for me, it's got to be, we've got to do it. Let's do it. Everyone's got to do it.
Excellent. Well, it was an unfair question, but I think it has illustrated kind of beautifully that, of course, it's everybody. We've talked about all the stakeholders, all the players, and the need for this collaborative approach, this general learning, and this kind of team working if we are going to have any prospect of hitting these kind of goals and timeframes. So a nice note to finish on. So in closing, a big thank you, obviously, to all our panelists there, Gareth, Alex, Hakan, Selene, and of course, Neil, and our sponsors at Altechnic. To yourselves out there in Zoom land for your comments and questions. A reminder to check out elementalexpo.com, the online community for professionals focused on innovation, heat, water, air, and energy, vital elements within the built environment now and in the future. As mentioned at the top of the show, in case you missed it, full diary of events on the website, upcoming webinars, and a back catalogue. And within about something like 48 hours, this session will be available online as well. And you should be able to share it with a link to anybody you think who would also like to catch some of the comments and insights. So thank you again, everybody. That's it for today. I've been Jim McClelland, editor at SUSMean. Thanks for watching, and we'll see you all again soon. Thank you very much.
Thanks, everyone.
Thanks to everyone.
Thank you.
Bye.